What I want you to do is I want you to model this think aloud technique in your own problem solving. And I'm going to ask you guys, with my help, to solve this next problem. So Megan, what was the first thing you remember about the think aloud technique?
What am I trying to find?
That's right. Whenever I come up to a reading problem, the first question I ask myself while reading is, what am I trying to find? And is that an easy process? Is that something that you need to do right away?
No.
You can breathe a sigh of relief. No, that comes usually at the end of a problem. So let's just take this first moment of reading through the problem to do it in a nice, relaxed way. Just sort of get a general idea of what's going on. Megan, do you want to read?
The admission fee at a small fair is $1.50 for children and $4 for adults. On a certain day, 2,200 people entered the fair and $5,050 are collected. How many children and how many adults attended?
Okay. Good read through. I get a sense of what the known information is. I get a sense of what I'm being asked. Now let's examine it again and look at an exactly what type of calculation is going to be required. Brandon, do you remember my technique for where and where problem I look at to find out? What was that?
It's typically at the last
All right,
sentence.
so let's read that last sentence.
How many children and how many adults attended?
Does that give you any hint as to what type of problem we're going to be solving for?
Yes.
What would that be?
Addition?
Addition?
Or, yes.
Well, is that from the word and? Okay, good. So we have addition. How many addition problems are there?
One each.
One each, being 1 and 1. So that would be two total problems. Is there an algebraic technique that has 2 problems?
Systems of equations.
Systems of equations. Very good. So let's set up the information that I'm going to need to solve the system of equations problem. I have 2 equations. I'm going to have within them 2 variables. So I'm going to add that to my board. All right, Megan, can you help me figure out what my 2 variables are going to be?
Adults and children.
Adults and children. Okay.
$1.50.
Okay, let's set up the equation using that information. The admission fee to the small fair is $1.50 for children. So we're going to do, you say that's correct? Okay. And I see $4 for children. So would you agree that that's how I want to set up my problem, my equation? Okay. That hasn't equal to anything yet. What is my equation going to equal to? Let's scan back to that problem. We'll have something times the number of children, plus something times the number of adults is going to be, and what is this something?
Money.
The money. So I have money for adults, money for children. What is that going to equal?
50-50.
Well, what I'm talking about
The
total
total
money,
amount.
The total amount, right? And does the problem tell us what the total amount is?
Yes.
50-50.
Oh, right. That's what you mean by this. 5,000 and 50. Very good. All right, Brandon. Let's set up the second equation. I have a certain number of children. Do I know how many?
No.
So let's leave that as x. certain number of adults, do I know how many?
No.
Nope.
When I add them together, do I know how many there?
2,200.
2,200. Very good. Okay, now we have all relevant information to solve for a systems of equations problem. Let's review what were the techniques or the think aloud process for solving a word problem. What's the first thing you do when you get a word problem? What are you going to do?
You're trying to find the question?
Ask yourself, what am I trying to find? Trying to find the question. Very good. Me personally, what that means to me is take a deep breath, relax. I'm going to read the problem several times, and I don't have to understand perfectly what it's saying each time. It's going to be a process where each time I read it, I'm going to be pulling out a specific piece of information that's going to be helpful. The second question that I ask myself is what, Megan? What was the second question that you,
What type of calculation is required?
and why is that important?
So you know what you have to do.
So I can set up the typical math problem and try and extract the relevant information. Yeah. And that leads me to my third part, Brandon, what is that?
What information do I need?
And when I have the process sort of simplified in this way, does it make the word problem seem less intimidating?
Yeah.
Now, do you think this technique could also be done in other types of reading questions that you might get? Maybe outside of math, maybe in liberal arts or science? Do you think there's the word is systematic? That means something that doesn't change over time. It stays the same. Is there a systematic approach to reading a scientific article?
Yeah.
What about a article, let's get out of the realm of science and just into fun. What if you pick up a magazine? Is there a typical systematic approach to writing a nonfiction article? So maybe there's a systematic approach to reading that type of article in a way which is going to extract the most information in an efficient manner. Do you guys ask yourself these type of questions before you come to a question for an English class or a question for a science class?
Sometimes.
All good readers really stop themselves in the middle of the process of reading and try and find the information and try and ask small questions to pinpoint exactly what information in the reading is going to be important and valuable for them.